Hey everyone, how's it going? Welcome to the stream. Okay, so as usual, let me start off with a little demo, explain what we did last stream. So those of you who've been watching, I've been working on implementing a C++ debugger, in particular implementing the DAP protocol, the debug adapter protocol. And last week I worked on implementing pointer types, pointers and references, getting all that stuff working properly. So here's a quick demo. If we go here, so here's a C++ program or C program for the Vectrex. I think it's already built. Let me just see. So we compile it. Yeah, it looks good. Hit F5. So that launches Vectrex, my emulator. Now I have this thing attached to debugger. Let's say I don't want to attach. So here we are. This is the emulator that's running. It's not rendering anything because there's nothing to render. But basically, it's the one that's translating all the commands that are being sent between, in this case, VS Code and Vectrex, my emulator. So these guys are talking to each other. Like for instance, if I hit F10 to step here, that's going to send a step request. In Vectrex, we handle it and we tell it what to do, and then it says, okay, where am I now? And it shows it, all that stuff. But basically what we're looking at here is what you see over here. You have variable A, and then you have a whole bunch of pointers and references, which are treated as pointers. And we have the ability to expand our pointers here. So these ones are the extreme cases of pointer to pointer to pointers, single references, single pointers. And if we step through slowly but surely, you can see all the pointers end up getting correct addresses, and that we can change the values through the pointers, and everything is reflected correctly through our local variables window here. There we go. So that's where we're at. Pretty happy with that. Now, in terms of implementation, I have a little bit of cleanup to do. Obviously, I was gunning to get this to work, and it's working, but now it's time to actually make this code look a little bit better than it is. So I'm going to start working on that before we proceed. And one thing I've been thinking about is this variables request data thing that I put together last time, where my idea was to sort of cache the variables that I've created per function. And I've been thinking a lot about it, and I think this doesn't really make any sense. There's no real need for this. I think what I'm going to do instead, because really in the end, all I need is, like, all of this is about, I get this variables request. Now this request, we will receive it for multiple reasons. The first and main reason will be because we are in the debugger, and the debugger says that, like, let's say we click on a stack frame, or we just hit a breakpoint. One of the things the debugger says is, depending on what stack frame we're at, like which frame on the call stack, it's going to make a scopes request, like this one right here. And one of the things about the scope request is that we tell it that we would like to, we set this variables reference. Right now we say that it's going to be a call stack index, and we give it the index. So for that reason, we're going to hit a variables request. In other words, the request is, show me the variables for this call stack frame. So that's what this is about. You know, if it's a call stack index, then we want to display all the variables for that call stack index, for that call stack frame. And that's something I did already like 2 weeks ago or so. And what we've done recently is, while we're doing this, while we are traversing these, if ever there's a pointer or a reference, we dynamically create a variable, like a child variable. Let's call it that, right? It's called a child variable. So you could see that, where is it here? So we traverse, and then over here for each variable, yeah, that's it. I created a function called create DAP variable. And the idea there is to take one of my variables and return a dap variable. But along the way, we check if it's a primitive type, then we just create a simple dap variable to display it. However, if it's an indirect type, which means a pointer or a reference in this case, what we want to do is we would like to populate the dap variable to return, but we also want to add to it a child variable. Now we don't do that here, but instead what we do is we populate another field of the variable that we are returning, and that is itself a variable reference of the variable, of the dap variable. So when we do that, what we're telling dap is this variable has a child. That's what this is about. So as I wrote here, create a child variable to display the dereferenced value. And then what happens is, without expanding it, we're going to see like a little, arrow thing. Actually, I could just show it instead of pointing. So let's say here, okay, we step in here. What you see here, this comes from a call stack frame, like the frame request. These are all variables for the current frame, for the current scope, I should say, the scope request. And so in there you see there's a bunch of pointers and references. For those, this little arrow here indicates that each one of these was given a child, a variable reference, which is exactly what this is about right here. If you expand it, then I'm going to get another variable request for that expansion. And I'm going to know because I'm going to check the variable reference below here. So come back to our variables request. We're going to hit another one. Like if I attach here, so here we are. Oh, apparently not running the same version. So let me just compile this here. Okay, let's try that again. Oh, actually, I did want to attach, but anyway. Okay, there we go. Breakpoints are valid. So if I try, okay, so if I step inside here, you're going to see I hit a variables request here. So this request is for the call stack index. So we see this if return true. I'm just going to hit F5, and that's what populates these. And then if I expand this one here, I'm going to get another request, but this time it's for the expansion, right? So here we go. It's a child variable. So in that case, we say, okay, well, let's go and create a dap variable for that child variable that is being asked for, and that's what we do here. So now we continue, and then that's what did this here. So basically it continues on and on. If I have, let's say, a pointer to pointer, expand once, we hit here once again, boom. And what's interesting here is because it's a pointer to pointer, the create dap variable will itself say, oh, this is an indirect. I'm expanding an indirect. So because it's a pointer to pointer, so it goes and creates the dap variable for this guy. And then it goes and creates a new variables reference for its child. So it says, I'm going to have a child, so let's do this. And then that's why the child one that we just got created, if we can expand that one now, you see? And what's interesting, you can see that it's waiting. It's waiting for a response for this expansion here. And once again, we come here, but this time it is a child variable, but it's not going to be an indirect. It's going to be just a primitive type because the pointer to an integer here. So that we just display as usual with no child reference. And then it completes here, and this one has no child. So that's basically the way this works. So having said that, I basically, all I need to do is I need to hold on to the memory of the, where is it here? This variable that I create. I'm creating a variable And I need to do this at this moment because it's at this moment that I know I have the information I need for this variable I'm going to create. I'm creating a child. In this case, I'm dereferencing a parent. So I'm dereferencing the current variable. So, you know, it could be a pointer to pointer, it could be a reference. So that's why I do this. I know the type at this moment. I know the location that, let's say in this case, it's a pointer or a reference. There's an address that we're going to have to read from to display its value. I know that at this moment. So I'm forced to create this variable here, but this variable has to live somewhere. Like there's an ownership problem here, right? It needs to live somewhere such that if the user expands it, I can go and retrieve it by some key. And the key in this case will be this index that right now lives in this variables array, which is part of this data type that I created. And that's the data type that I want to revisit. I do need something similar, but I don't like this idea of keying it off or having some kind of storage based on function. So I need to do something a little bit more flexible than this. So all I'm going to do is, rather than have this function address and have a vector of unique pointers, I think what I'm going to do is something along the lines of this here. Actually, let me just leave this here. Let me make a new type. So what I'm going to do is I'm going to have some kind of new type to manage this, and I'm going to call it like dynamic variables or something like that. Yeah, and we'll do add variable. So here, this will adds a variable and returns a unique ID. The fact that it's an int doesn't really matter. It is an int on purpose because I need to store this in a DAP as a variable reference, and so that's the reason for this. But it needs to be unique, and what we're going to do for that is we'll have some kind of counter, you know, ID counter, which starts off at 0, or it doesn't really matter, but it starts off at something anyway. And we are going to have a hash map, or an unordered map, I should say, of int to unique pointer. And it's a unique pointer of variable, like this. I'll say ID to variable. Hey, what's up, Ashamuk? Or Asharnuk? Sorry. Where's my indentation? What do you mean by where is my indentation? Oh, I see. You don't find this indentation good? I'm using a Clang format. It takes care of it for me. What's up, Mistran? Yeah, I like it like this. I don't really have a problem with the indentation. Okay, so basically, I do something like this. Now, the other thing is that what we want to have, it's basically like a temporary cache for a variable. You know, so what we want to do is we want to be able to add it in there, and then we want to be able to retrieve it, and when we do, we can remove it. So that's basically what this is. It's kind of crappy that I have to do this, but it's not really my fault. It's because of the protocol. This isn't VS Code, actually. This is Visual Studio. I am using VS Code, though, for implementing my debugger there, but what I'm actually programming in here is Visual Studio. Okay, so something along the lines of not an amazing name, but it does say what I mean here. So basically what I want to do is like this. All right, man, thanks. Okay, so I'm just going to do this here. So we erase this guy from the map, and we return our unique pointer. Right. Am I married? I'm not sure why that's relevant, but I am. So the idea behind dynamic variables is it sort of acts as a temporary cache, I suppose. You can think of it that way. And the way I would use it is, now of course I'm going to move this into my header properly there, but for now, just as I iterate, okay. Yeah, so we're not going to do this anymore. This guy here, we're going to change it to accept a, what did I call it? Dynamic variables. Okay, so here we pass the m dynamic variables, same as here. I am actually not married to a guy, but I'm not really, I don't really want to give away, you know, private details of my life just like that, so don't see how it's relevant to the stream. Okay, so here for index, which I'm going to call ID actually. Did I call it index because I did that in my variable ref here? No. Okay, so I'm just going to put ID. All right, man. Thanks. Okay, so we add the variable here. And all right, now I need a way to remove it when we actually need to retrieve our variable. So that's going to be here. So, in fact, I guess okay, I'll just do that for now. So that in this case, do like this. So now we're actually getting back our unique pointer. Const variable ref. So I think I need to dereference it here. And then when we fall out of this scope here, this variable that we just got back will get deleted. So it's basically just lasting long enough for us to actually populate the dap variable, and then after that the memory is freed, which is what I wanted to get at. As opposed to just sort of keeping a whole bunch of these variables allocated and hanging around, which is what I was doing before. It was completely useless. So I should be able to remove this now. Let's see if this builds and works. It's failing to link because I still have it open here. Build again, should link. All right, so, oh, something went wrong there. Okay, so somewhere I have a small mistake. So what we're gonna do is we're gonna attach. Probably hitting my assert or something. So let's expand here, and this is where things go wrong. There we go. So what's our problem here? So we are trying to delete our variable and it's not liking it. Why is that? Critical error detected. Okay, let me see. Okay, so we attach. Okay, I'm going to remove this breakpoint here. So let's expand. Now we hit this breakpoint here. So this is the problem. Something is with my logic here. So we're going to do a find. So there we go. So we have 7 variables, which makes sense. You can actually see the names here, star P, star P2, and all that. These are all the variables that have been added dynamically because these are all the indirects. Now we're about to expand the one at ID 0. So that would be this first one here, which is star P. That makes sense. So we're going to do a find. We're going to find it. Now, maybe this is the problem, is that I thought I could erase this because my iterator here has, I see it uses shared pointer. Is that what it does? No. Okay, second is unique pointer. So the very fact that what does that mean actually? I suppose I can't really have a unique pointer there. What does it mean to have an iterator with a unique pointer if the container has unique pointer in it? Since there can only be one thing pointing to it at once, right? Okay, so no one's really talking about removal. So okay, that's what I think I have to do. I have to move it here. So yeah, so this looks like pretty much what I'm doing. Oh yes, that's true. That's a very good point. Wouldn't the iterator usually just be a reference? Okay, did I miss that when I was... You're right, it is a reference, isn't it? If I look here, second, we should see a ref. Normally, you're right, it would be a reference, wouldn't it? I don't know why it doesn't show up as a ref here, but you're certainly... Normally it is, yeah. So here what they're showing is it's exactly the same idea, right? Right, some sort of pointer, yeah. So that I guess it's kind of funny, right? Okay, so the idea is that this iterator here, though, you can move it into a local, and then you can erase using the iterator. So that really does kind of beg the question of how that works in terms of ownership, right? Because this sort of implies that the iterator second here is the unique pointer. Okay, it's just erasing it. That's not helpful. I just like to understand it, because here it gives me the impression that the type of my iterator is one that, okay, let me see here. Std list iterator, std pair, int const, std unique pointer. Yeah, it's just a unique pointer. It's not even a reference. Huh. Okay. Well, ostensibly, the way to do that is to do this. Let's go like result equals to, let's do our move that we're doing here into a local result. Then we erase, and then we return. Apparently that's the way to do it. So let's see how that works out. Let's just go for it. All right, that looks like it's doing the right thing. So I suppose unordered map, like it's somehow, probably it's storing the iterators. That's probably what's happening, or storing those pairs. And so really the iterator is just a reference to the pair itself. And yeah, so it's not a copy of it or anything. It's the thing. And so when I'm moving, I'm actually moving the unique pointer. Technically, I guess I'm moving it out of the map. So after that move, actually that would be interesting to see. Let me see here. I don't know if it's gonna restart. Let me see. If I just do like that, let's attach. Okay, there we go. So let's see. I'm just really curious about what's going to happen here. So if we expand my iterator and we expand the map, at least the view here. So now, see, now we're at 13 because we're just ever increasing. And we are about to do a move. So let's see what that looks like. So there you go. So you can see here it says 13 empty. So yeah. Just by doing that, we've already removed it from the container, which makes sense. So that's interesting. And then after that, we erase that guy from the container, so no longer has 13 in it, which is what we wanted, and we return our result. Cool. So I like this better, so I can get rid of all this stuff now. Now we can actually start cleaning up this code. So let's move dynamic variables here. Okay, so we do that. Now this guy, we're going to actually make this a proper member function, which is the plan, which means I won't need to do this anymore because those are members. Meant to call it that. Okay, so let's create that variable, which is here. Just gonna look for, this is gonna be m underscore. I think there's gonna be, where's my memory? Oh yeah, that's fine. Okay. Yeah. Usual. Oh, okay, it's a struct, so it's not a variable. Sorry, it's not a class, so I forward declared it as a class here. Struct. Cool. Okay, this looks good. So there was another thing I wanted to try, which is related to this, which is just having a function that does this and then calling it a couple times. So let's say I just have like a good old foo. And just something dumb like this. I just want to have a few call stacks, and I want to see that the pointers have different values and that they do the right thing. Yeah. So let's see this build. Okay, so there are all our garbage values here. What I'll do is I'm just going to put a breakpoint here, hit F5 a couple of times. And I think the count right now is, actually I'm not displaying local variables yet, but this should be the third one. Yeah. So if I just leave it like this and I show the call stack, so there's main, there's this guy, and that guy, and oh yeah, that guy doesn't have anything. So basically these two calls here. So the one for 0, the one for 1. What happened to my 2 though? 0, then this becomes 1. This becomes 2. I should have had 3. Let me try that again. This is 1, 2, 3. Oh, okay, there we go. I think I just hit F5 one too many times. Oh, and I suppose no, this should be good. So if I come down here and expand 14, this one should also say 14. Oh, it's cool. It actually remembers the expansion. So, okay, so the thing to notice here is that because these are all stack variables, like A is a stack variable, and then all of these are stack variables that point to A. What we're seeing here, this address is the address of A currently on the stack. And of course, that will change depending on the stack frame we're looking at. So let's say here on the very first call, A is at CBDD. And then when we go into the next one, it's at CBCB actually. So first thing to notice is that it's the value is smaller in memory, which makes sense because the stack grows in the negative direction. And then the next one should also be smaller than that, and it's at B9. And in fact, the offsets should be the same. Since I'm not good at doing hex math in my head, let's do this here. So from CBDD, so DD to CB. So we'll go DD minus CB. So that's 18. So that I guess that makes sense. 18 bytes or so between them. Each one of these is 2 bytes, so like 2, 4, 6, 8, 10, 12, 14. And I guess we count the next. Actually, I'm not quite sure. It is 18. 2, 4, 6, 8, 10, 12, 14. Okay, so I'm not quite sure, but let's just make sure that at least the offsets between the next two make sense. So CB minus B9 is also 18. Okay, so that makes sense. So everything here looks like it makes sense. So that's the only thing I wanted to double check on. All right, so I think this is in a decent state for me to commit, so we can move on from this. Oh yes, I wanted to move this to core. Okay, so let me start doing that. So first things first, we're going to go into debug symbols. Move to core strong type. So let's do that. Just going to open this here. Okay, so strong type.h. Regen the CMake cache just because I use recursive, I use globbing to find my files. It's a bit long. Come on, you can do it. Sometimes it takes a long time to regen. No, it's just that I have basically, so Visual Studio has this like support for CMake, and you know, like it doesn't really matter whether I glob or not. Let's say I had the list of files. I would have had to go into CMake and change it, and then Visual Studio would have noticed that I modified the CMake file and automatically reloaded it. Since I'm not doing that, I'm using globbing. I have to tell CMake to regen. So I say generate cache, and then upon doing that, it then regenerates and reparses and populates it's CMake targets view here. So now we should see strong types. There it is. Yeah, basically that's what it is. So yeah, and if maybe you were asking me what I meant by globbing, just I want to show you here. What I mean is this here. Basically, when I collect the source files, say for a given modules, in this case it's libs core, so it's all the ones you see over here and the source. So all of this core static library, all the source files are collected using glob recurse source files here. Yeah, exactly. Yeah. So then, if that's what you meant, that's exactly right. And as it turns out, so this is actually it's not recommended for CMake, but as of CMake 3.12 or 13, I forget which one, they actually added a new feature to the glob recurse. Yeah, that's right, to glob or glob recurse, where I forget what it's called, but you can. Oh yeah, it's called like depends. Let's see here. I'm looking for the file command, and there's something about configure depends. I think that's what it is. If the configure depends flag is specified, CMake will add logic to the main build system check target to rerun the flagged glob mod commands at build time. And if any of the outputs change, CMake will regenerate the build system. So I haven't messed around with this yet, but apparently this sort of solves the problem. Although, as you can see here, we do not recommend using glob to collect a list of source files. If no CMake list text file changes when a source is added or removed, the generated build system cannot know when to ask CMake to regenerate. So that's why I had to opt into it myself. I had to actually force it to regenerate. The configure depends flag may not work reliably on all generators, or if a new generator is added in the future that cannot support it, projects using it will be stuck. Even if configure depends works reliably, there is still a cost to perform a check on every rebuild. So that's, I guess, the caveat to using configure depends. To be honest, I don't really care. I haven't really found it very painful for me to just regen those on those like super rare occasions that I add a file. But, you know, maybe in a bigger project with many, many more files, I might be, or with, say, more like, not many more files, I'd say maybe on a project with lots of team members where this becomes a problem, maybe go ahead and list the files. Okay, so I just wanted to move all of this into here. Okay, so that should take care of that. All right, so DAP debugger. Let me go take care of that thing. I should start using CMake for some cross-platform stuff. Right now, I tend to use GNU Make and right. Yeah, so you know, I feel like CMake, you know, it's definitely not amazing, but it's become sort of de facto, right? It's like the sort of de facto standard now in the C++ open source world anyway. So it's sort of like at one point I figured I may as well learn it, and I took the time. You know, I invested the time. Originally I had like a simple CMake list at the root, and it sort of collected everything, and I sort of just hacked at it until it worked. But over time I started suffering from that, and I was like, I need to modularize, and yeah. So then I looked into, if you really want to know like more about CMake, hold on a second. Sorry about that. Yeah, so I was just gonna say, if you want to learn more about it, like just like Google modern CMake, and read about the modern way of writing CMake. So because CMake is old, right? It like dates back from like the 90s, and it's gone through many iterations. But in the last few years, I don't know at which version it started, but at some point they started doing this. They changed the whole idiom, the whole model of how to define what they call targets, right? And they added a whole bunch of like new commands that are target based, and it's really the thing that makes the most sense. Like the whole idea that rather than the old school method of doing things, and this might sort of be true for, I've seen this with GNU Make. It's sort of a problem with Make in my opinion, but maybe I don't know Make enough. But like the idea that rather than say, okay, I'm writing the make file for my executable, and I need to use this library. Typically, what we would do is we would say, well, I need to add the include directory for it. I need to add some linker, add the line to say link against the library for it. Perhaps some preprocessor defines that need to be defined for it, so that when I include its headers, it does something. And you normally do that all in the executables make file. And that sort of sucks, because like if you have 3 executables that all have to include that thing, and then they'll sort of repeat themselves, or you find some way not to. But the idea behind targets is that it's you invert that. The target describes everything, right? So let's say the library itself, its CMake file, and in fact I can just show you here. Well, maybe I'll choose one less complicated one. Yeah, this is not too complicated. Basically, this is the CMake file for my emulator, for the core of the emulator, and basically what I'm saying is, so this is the emulator. This is the list of files for it, right? The source group here. But the key is here. So we say this is a library that has the name emulator, and these are its source files. You can ignore this. And then this is the target-based stuff. These are 2 target-based commands. What we're saying is emulator has a public include folder, like an include directory called include. It's actually it's a relative path to where this file is right now. So if I open here, what I'm saying is this folder here, add that to the public includes. You can also have private includes, which means that only when it gets compiled, only its CPP files see it. And then over here it says, also, by the way, I need to link, I depend on publicly the core module, which is a separate one with its own CMake. And so this way, whoever depends on emulator automatically gets the include directory, and it also automatically depends on core, like publicly. So it gets the dependencies of core as well. So everything is transient, right? And you have the concept of public and private, which is really nice. So like if this was private, it would mean to compile this guy, it depends on core and will link against it. But if somebody else depends on emulator, it won't implicitly link with core. So anyway, that's the whole idea behind it. I think it makes a lot of sense, and it's worth spending the time to learn how to do modern CMake if you ever decide to go down that route. it's definitely, I think, the right strategy. Everything else to me is just a bunch of hacks and setting global variables and stuff. Make has variables that can solve the issue, but it's a mess on Windows where you'd rather have some tool generate. Yeah, that's the other thing. Yeah. Yeah, if you know CMake from the 90s, that's not what we're talking about anymore. That's a whole other, it's almost another language, really. It has definitely improved a lot. So yeah. All right. So where was I? I was looking at the tab debugger, I think it was, and I wanted to remove this guy here, 214. Okay. Can't read this diff anymore, so let me use my beyond compare. Right, because I factored out all this code into the create dap variable function, so it's a bit difficult to read, but it's all right. General gist is there. This is actually new code. What's going on here? Source request. Did I actually change this? Huh. Don't know why this got reformatted as it did. So Clang format just decided to reformat this? That's weird. Oh, here too. Why? Why do I have all these formatting changes? That's unexpected. Let me see here, 676. Call instruction. So I think my line length is like 100, so let me see here. Yeah, this should have been okay. And you see now it did the thing. See, now it's, wow, it's so weird. Okay, I'm just gonna copy these back here. Yeah, that's just strange. Okay, that's good. I think this is all good now. Oh, is this? Yeah. Oh, yeah. This was the other one that I didn't understand. 459. It's not 4. Oh no, 409. So this. Okay, so if I copy this back, I don't like when there's inconsistencies in the formatter because that sort of worries me. See? Why did this happen? Okay, I think I did that. That's all right. No, let's do that. And that's my new function. All right. So that takes care of dap debugger. Okay, RST parser, yes. Location became a union. CMake lists, okay, that's fine. All right, so we add this guy, this guy, this one, and that one. These are just local changes that I keep around. Okay. Yeah, so this is the first time I see this happen here. So I use Clang format, right? And you have to be careful with Clang format because, like, if you have multiple versions of it, it's going to format things differently. But in my case, I always format you through the extension that's installed here in Visual Studio, and I don't think the extension got updated. So if it did, that would explain what's happening here. But that's, I didn't really do anything with that. So I don't know why it got formatted differently. That was very odd. Anyway, trying to think if I used, because I know VS Code also has Clang format and it uses a different version, but I don't tend to edit my code outside of Visual Studio, so I don't know. Very strange. But yeah, I don't like seeing diff noise in my changes, definitely. Okay, so here, I just looked here. Last time I worked on that, I wrote that debugger and I said, see, support display pointers. Support display pointers. That's kind of strange. I meant displaying pointers. But now I'm going to say support displaying, or let's say fully, I don't even know how to say this, implement pointer reference or pointer expansion, maybe, to show pointed to value. There we go. Okay, this is cool. Now the next thing that I need to work on, come back here, is going to be, I think, well, oh yeah, there was one more type that I'm not currently doing correctly, and that's bool, which is tied to enums. So that's one thing. And then another one, and the next big one is to start working on structured data types, which is like class, struct, and union, basically. So I guess we can do bools. That should be pretty. Oh, hey, thanks, Coding in Quarantine. Nice name, by the way. Thanks for the follow. So yeah, I think getting the bool case to work shouldn't be too difficult. And in fact, it would actually mean supporting enumerations in general. The main reason I watch programming streams at times is because it's fun to see the different workflows people have. Yeah, I agree. I like to watch programming streams for that reason as well. See how people work, the tools they like to use. And another reason I like to personally watch other programmers, and also a reason I stream myself programming, is I like to, I sort of like to, sort of demystify the whole thing of like, how can I say, that whole idea that like, programming is really something that most people do very privately. Programming itself is sort of like a private, a personal endeavor. Even though you might, be a programmer at work, you don't tend to, except if you pair program, but you don't tend to program with other people. And so the whole process is very personal. And so I think people will get the wrong impression that what they do or the way they work is very different from others. And that, I think a lot of people suffer from that imposter syndrome of like, you know, if somebody saw me and watched me program, they'd see how much I suck, or like all the mistakes I make. And we tend to look at others and we just see their, you know, their highlight reel, right? Like we just see the result of their work, but we don't see the struggle. And I feel like that's something I like when I started watching other programmers, is like, hey, look, you know, they struggle too. We all do. And I think it's important to see that. So that's one of the things I like about streaming, is you get to see me fail, you get to see me stumble, you get to see me pull out calculator here to do stuff that I can't do in my head, and you know, and you get to see me Google how to like use an unordered map of unique pointers. You know what I mean? I never make mistakes. All my code works perfectly and optimally on the first try, except when it doesn't. Yeah, exactly. Yeah, I think that's sort of like a good thing, is just to see people, you know, we're all the same, really. You know, programming is like that, right? It's a lot of trial and error and iteration and banging at it until it works. Sometimes not quite understanding why, and then it sort of clarifies itself later. I think another reason I like to do this is because I think I realized something about myself, which is that I'm a really even though I'm generally an introvert, and you know, like to be myself and be with my thoughts and do my own thing. I'm also like strangely a social programmer. Something I discovered about myself years ago when I would, you know, in the early days of like ICQ and internet and all that, and like I'd be programming, and I realized that I really liked having, you know, my friends in a chat on the side, and just having the knowledge that they're there, and I could share snippets of code or little triumphs that I had. And I could really feel it, like those times where, I don't know, internet was down and I'd be sitting at my computer trying to program, and I'd not feel like doing it for some reason. You know, I'd just be like, I wish there was someone online that I could talk to or share this with, or know that they're doing the same, you know? So that's just me. Just a sort of realization about myself, which is weird because when I started programming, I didn't have internet, and did spend hours by myself doing it, but you know, it changed. Though to be fair, when I did start programming, I did have like some close friends of mine live nearby, and they would typically be in the room, so it's sort of similar, I guess. Anyway, yeah, so enums. So let's and bools. So let's take a look at what that would look like. So if we just kind of comment all this out, another main, and let's just add a bool. Something like this. And let's see what the code looks like for this. All right, so there's our bool type. And at least for this fork of GCC and for the way it generates stabs info, it considers bool to just be a type of enumerator. And I know that's because of this E here. And what you can see here is that it's saying bool, which is type number 22, is equal to an enumerator that has these values. False is 0, true is 1. And then there's actually a comma here, and then no more values. And then if we drop down to usage here, we can see that A is of type 22. So that's what we saw here. So type 22 is that enum here. So in my case, even though it is an enumerator, I'm going to want to treat bool specially, because I think it's going to be weird if I actually display E false and I mean if I display false with a capital F and true with a capital T and say that, well, I guess the type would be bool. So I guess I could do that. I guess it would be the same. Just look a bit funny because in C++ we don't typically capitalize true and false. So I might have a special case. Maybe I'll say like if it's bool, make the names lowercase. Maybe that's what I'll do. But before I do that, let me actually add another enum just so that we can sort of compare what those look like. So let's call it I don't know, weekday or something. And I'll put 3 of them. So we do this, and we'll say weekday equals to Monday, and then Tuesday, and Wednesday. Okay. So let's build that and take a look at what the data type looks for that. Okay, so here is stabs for weekday. So you can see that it's pretty much like bool. So we're looking at this guy here and this guy here. It created a new type, type 25, equals to E again for enumerator. And then we have Monday, which is 0, Tuesday is 1, Wednesday is 2, ending with the comma. So no big surprise there. And D is of type 25. So one thing I'm going to have to contend with here for enumerators, I can obviously just display the integer value, but ideally in a debugger we'd actually like to see the string that represents the enumerator's value, not just the integral type. So I'm going to want to save that data. So yeah, we're going to need another type for this with some kind of vector of strings or something, or some kind of map really, because these values are not necessarily consecutive, right? They can be any value to a string. So yeah, we're going to store some kind of map, mapping the values to the names. All right, so let's get that done. First, we're going to go to my RST parser. Enums could even have duplicates. That's true. I'm not sure what does a debugger do though in that case. Probably just picks one, right? Like, what does Visual Studio do? That's actually an excellent point. Thanks for bringing that up. You're right, like if we went here and we just said like end of days is equal to Wednesday, don't tell anyone. Whoops, what did I just do? I get confused because my shortcut keys from Visual Studio don't necessarily map to VS Code, so then I get myself in trouble there. So yeah, so here you can see that it just has the same value, of course. Now in Visual Studio, if we were to do the same thing, let's go into like my main or something. Okay, so D says Wednesday and Wednesday. So there you have it. It basically just picks one. In this case, it doesn't really care that there's another day. As far as it's concerned, the first one is the winner. So we'll do the same thing. When in doubt, I do as Visual Studio does. All right, so let me see here. I'll grab this. Now let me think. How do I want to handle this guy? So most likely I'll have an add enum type, which will be a new type. Now in terms of parsing, it is an LSIM, but it's not the typical LSIM, and it's not, yeah, because I have a regular LSIM match here. Then I have a pointer type, so I guess I'll have one for enumerators, which would make sense, because the difference with the pointer type here is I'm looking for equals star, and in our case we'll look for equals E. So yeah, let's do that. I'm trying to think if there's anything else I need to worry about for enumerators. In our case, it's C++ 03, so I don't have to worry about typed enums, enum class, and all that. So it should be, I think it's fairly straightforward. I suppose the only thing I don't know is what's the type that the compiler decided to back the enum with. That is actually a complication, right? The amount of memory that is decided to take, but I don't think, yeah, I might need to know that in terms of reading the value. You know, like for instance, most likely this well, not the bool, but let's say the weekday here, which is type 25. I don't actually know how large, like how much memory it takes. So let's say I add like another value here, you know, whatever, foo, and I give it, you know, some kind of large value, like 6,535. Error. This. Oh, actually, is it that enums are always backed by an integer? I forget now. No, I don't think so. It can take less memory. The compiler is allowed to use smaller amounts. Here it says error, this decimal constant is unsigned only in ISO C90. Oh, do I have to say it's unsigned? Is that why? Okay. So now, do I have any extra information here? Huh. Interesting. That's the first time I see this. So that's an interesting complication that's probably going to affect anything that can span out. So enums would be one of those. And probably the same going to be for like structs and stuff. Anything that has like, you know, something that can be long, I'm going to have to look for this unfortunate character to know that I have to parse the next line. Yeah. Yeah, exactly. So that's the thing, right? So, okay, so one complication like I see here is that I'm going to have to parse out potentially multiple stabs lines to get all the information for an enumerator. So I'm glad I added that just to see this case. And then the other thing is that, the other thing is I don't think I have any sense of how much space this takes still. I think I can get an idea here for if I add, let's say, another variable here, like an integer. So if we look here, okay, so C is at offset 3 from the stack here, and D is at offset 1. So we can see that it's 2 bytes away. Yet, if I remove foo here, will it be 1 byte away? Let's see if this 3 changes to a 2. And it does. So you can see here that the compiler did decide to increase its size. Unfortunately for me, I don't have that information in the data type description. Really sucks. So I guess I have to figure it out myself based on the values. I'm gonna have to basically try to, like, I guess, you know, I'll have to look at the range of values and assume in this case, and I think my assumption will be okay for GCC anyway, but like that it's going to allocate the smallest possible size that can fit the values of the enumerator. Which it's a fair assumption for this specific fork of GCC because it's targeting the Vectrex. It's basically targeting an embedded system. It's not targeting Vectrex, it's targeting the 6809, which is an old CPU. And so far, all the choices in terms of code generation have been about keeping the code compact. Although that might actually be the compiler options that we pass it. So it's, yeah, this is difficult. This is where you see the problem of using the stabs format. It doesn't actually give us a lot of information. We have to do a lot of like guesses. Yeah, if you give it a negative enum values, it's the same similar problem, right? So we could try that here. Like let's say we give it you know, I don't know, a large negative number. Let's say negative 50,000. Although I think it might complain about, again, it being signed. Yeah, this decimal constant is unsigned. It actually wants it to be unsigned. Strange. Can I not give it a negative value? So as long as it's okay, so it looks like it's okay with a small negative value, but as soon as I make it large, it seems to complain. Like probably 5,000 is okay too. But if I do minus 50,000, it's unhappy. But okay, let's go 5,000 anyway, because that doesn't fit in a byte. So let's just see what that looks like. Are we at offset 3? Where are we here? Already forgot. Looking for C. Yeah, so you can see it is 2 bytes large. Because in order to you know, support this range from minus 5,000. Yes, that's right. Although I don't know if it matters so much. I mean, I guess it matters a little bit, but if I store all the values as unsigned and just read it back, in terms of my debugger, you know, I just need to display this value here. Although I guess I should display the, apart from the string, I should probably display the value next to it. So yeah, if I want it to be really pedantic, I would have to store whether it's going to be displayed as signed or unsigned. But if I ignore displaying this value, I could just store everything as unsigned, read it back, and do the lookup in an unsigned way, and it should work. But yeah, I might have to store an extra flag there that says this range has negative values in it. Yeah, indeed, not even something as simple looking as an enum can be quite complex to parse out. This really bothers me. Oh, it's very unfortunate. Because it's really nice to be able to parse these stabs lines just as single lines and you know, treat them as such. I think I can easily solve this problem though. Maybe what I could do to solve this is kind of do it at a higher level. So as I'm parsing, if I parse a stabs line, I could check to see if the string component has this in there. If it does, read the next one and sort of do that in a loop and do the combination myself. You know what I mean? Basically, eat up all subsequent stabs lines and combine them into one, so that foo here minus 5,000 would move into the slot there, and then that's the line that we end up parsing. So it's like a virtual line that gets created. Because I suspect that I'm going to run into this for like structs and stuff like that. And let's take a look. I guess I should give these longer names, assuming it has something to do with string length. Yeah. So you can see here that my struct does the / thing here. Now, if it was not so large, what would it look like? I'm just looking because I see these 2 semicolons at the end. Is that? Yeah, okay. So, huh. What's going on here? Oh, okay. So it looks like for structs, and probably same for classes, there's actually the... This is so confusing. I'm going to add some spaces just so we can see this. So this is the data type itself, and then there's another type related here, which I think this might be that thing about how you can type def a struct, you know? I bet you it's this thing. You know how you can do this? Let's call this like my struct is awesome. So let's see. No, it's not. Okay, so it's another thing altogether. Okay, so forgetting that part. So it looks like, anyway, for a struct, so type defs is a whole other story. For a struct or class, it has this one definition followed by another one. And the only difference between the two is that this one here has a small, like a lowercase t. And anyway, here's a simple example, the struct here that doesn't take multi-lines, which has the same deal going on there. So I probably would just ignore the second one because I don't see what value it would have for me. And maybe it'll, you know, maybe when we work on that, it'll become clearer where the second one comes in. And I guess I could read about it. But for now, what I really want to see, and this confirms it, is that I could write my parser to join subsequent stabs lines that are too long by replacing this bit with this bit from the next line. Oh, and actually what I want to see is, what if I have many more of these? Like, can it go to 3 lines? Can it go to, you know, I suspect so. Let's just change one letter here. Okay. Yeah, so here we have a multi-liner. 1, 2, 3, 4. And then here's the, and all of them have this / at the end. Yes. Okay, fun stuff. let me actually, to make my tests easier, let me do this. It'll be easier to debug if I can actually see this properly. Okay, there we go. Okay, so here's the get line that we're talking about. So let me see if I can do something here. So we get a line. Maybe this is the function that I need to change. I have two choices. So either I can do it at this level, which is probably the level I have to do it at, or I can do it where I know I'm parsing specifically as stabs, but then at that point I think it's weird to go and like do yet another line read. Maybe. So where's my stabs here? So it's the, oh yeah, it's the string one. Stab string match. I have one here and only one, right? Okay, let me do it at the higher level and see how that goes. Because I'm also thinking maybe it's not just the stabs, it's not just a string format that might end up being longer. Maybe there's other ones, and I'll regret having done it here. And also, if I want to do multiple string matches, then it'll, I'll have to repeat myself and all that stuff. So let's sort of like do it up here. So I'm going to start off with a local function, and we'll see where it takes us. So I'll do like read next line or something, or maybe I'll just call it get line. And it will take my if string here and a line by ref. I'll probably hoist this out into its own thing, but for now I just want to try this. We'll do this. Oh yeah, and this guy's going to have to return a bool. So what really sucks is I'm going to have to be doing this kind of stabs matching, this regex match for every single line, which twice in effect if we go down this path here. But basically for every line. Whoops. And in this case, the stabs string match, we care about the string portion. I wanted to write ends with, but the C++ types are not awesome. Yeah, std string is crap. I know. Yeah, it's missing a lot of functionality. Maybe I could do substring. Yeah, let's do that. Let's grab the substring at s dot. So it's basically size -2, I think. Maybe it's 3. I always get this one wrong. If that's equal to this, and of course I'm gonna have to escape it, or I can make it maybe a raw string. Yeah, I would like to avoid overdoing the regex things, because I'm already doing a regex match here. So if we did match a string and we did get an end, what I would need to do now is to replace that bit with the next line. And I need to do that in a loop. Fun stuff. So in that case, I think I'm going to take off the ref here so I can modify line. Okay, so while this is true, grab the string portion, make sure that I can substring it here and that it's equal to this. If it is, I need to take this. Yeah, is exactly why I don't like using std string. Actually, I have some string utils that might help me that I wrote. I could use replace, although this is not necessarily the fastest. It's going to actually do a search, so that's not amazing either. It's always the problem, is that it's hard to make efficient general stuff. Because now I know that I effectively want to remove this last bit and then add append at that location by reading the next line. Okay, so let's say this is the case. We do this. What do I do? Can I erase at an offset? Okay. So let's erase at this offset. So let's do this. So go like this. Then I want to effectively read the next line. I'll clean this up after. And what we want to do is do line append next line. Well, not actually all of next line. So now from the next line, I need to do again this parsing. And we expect this one to actually be the case, that we get another stabs here. Okay, so now what we do, I wonder if I should do this like recursively and then sort of replace and return, replace and return. So much stabbing. Yep. Yes, indeed. It's gross code. I'm not sure how to do this in a clean way just yet. But it would be something like this. And now that we have this line, so effectively what we've done is we've replaced the backslashes with the string portion of the next line. Now we want to take this line again and do the exact same check on it. So we want to rerun this if. Yeah, normally I would recurse, but actually I think we could do this with a simple iteration like this, and it shouldn't be too bad. Yeah, basically this portion here, that's going to become this guy there. So in that case, I can actually do like this. It's a little bit ugly, but I think it's okay. And then this becomes a while loop here. And then this is not a while loop. So I am sort of repeating myself here, so I could probably fix this, but this sort of like primes the loop here. We come in here, the very first time we match, we know this is a string. Yeah, you're right. Yeah, should be a ref. Not that one. Actually, I need to replace the S here. So yeah, I think I'm going to keep it that way. Okay, let me just run through this in my mind here. So we come in, we grab this line. Oh yeah, and at the end we want to return the line. Now, if the line is a stab string, we grab the string portion. This is effectively const. So we grab the string portion and we check. If it ends with this, erase that bit from line, grab the next line, match the next line, and now we just assume it. We just take the next one and we just say, you know, first of all, replace s with that, which basically is the same s that we see here. Stabs.string, it gets replaced here for our loop, and append that string portion to line, and then go again. So now the new s, is that what we want to check? If yeah, I guess so. Although, yeah, I guess that's okay. It's a bit confusing because I'm checking the substring portion to see if at offset oh no, this is wrong. This offset's no good. Yeah, no, that's not gonna work because that s's size keeps changing. So I am gonna have to do this here. And then, yeah, this is gross. Oh, God. This is what string code always looks like. Okay, so let me go again. So we prime s here. So while I can get its substring, why is it? Oh, there it is. Okay. So while I grab its substring, if it's equal, so if it ends with this, we erase from line the last two characters. Yeah, I mean, I didn't really have any choice here, right? This is the format I have to deal with. And I mean, this is terrible. Really, they couldn't just put it all on one line. And you know, this is what this format looks like. I'm sure someone's going to come along with a stabs format that is slightly different and doesn't quite pass my parser. And anyway, I'm pretty much tied to this one version though of GCC for Vectrex, so I think we should be okay. Okay, now we grab the next line and we do another match, take its string portion, add it to our lines, we append it there. So I suppose I could, this doesn't have to be done up here. Let's do down here so that we see that what we're doing. We are replace the / at the end of line with the string contents of the next line. And then we loop again, because if this next s that we just parsed out also has another / at the end, which is the case here, so we've got this one, so we're going to parse this guy. Now we're going to look at this string here. If it once again ends in / or // we come back in here and then we read again the next line. And so we keep doing this until we no longer we no longer read a double /. So I think there might be one mistake here, is that I read this and I append it. Oh no, there's no mistake. And the last one, this is how we terminate in this case. We're going to read one more stab string line that doesn't have the double / at the end. So that's going to break out of our loop. And then we will have a line to return. What's the problem here? All right, I went for bool. I didn't want to do that. Okay, this has to be a ref. Yeah. Okay. So that's fine. Why did I make it a copy again? What was I thinking? I wasn't thinking. It's because I read into line? I only read once into it. Okay, yeah, so that should be okay. All right, so let's see if this works. So we're going to replace our call to std_get line with just good old get line. It'll be fun. And just to like speed this up, I'm gonna just copy this right to the top. If I want to debug it this way, I'm going to have to just change my launch options here. I don't know why this keeps happening. It keeps losing my launch options here. And I need a path here to Vectrex Pong. All right, so here we are. So we're about to parse the first line. So let's go into getLine here. And oh, it looks like, did I not save my? Oh yeah, so okay, the first file it parses is not this one. So you know what? Let me shove this into the other file. The first one is another RST file. CRT0, this one here. All right, let's try that. I think that's the one it's trying to parse. Let me double check. Oh, Vectrex Pong. Okay, that's why. My bad. Let's go back to what I had. It's not Vectrex Pong, it's Vectrex empty that I want to use. So this just happens because this launch JSON file, for some reason, it gets reset at some point. Maybe it's when I regenerate CMake, but it's not supposed to do that, at least with my experience with Visual Studios. Like this shouldn't even say add debug configuration. It should say edit debug configuration because it has one now. But there's some kind of weird bug with my Visual Studio because the one I use for work doesn't do this. Anyway, let's see now what it parses. Did not like, oh, I think my path was wrong. I tried to be efficient here, but this is, okay, no, this is Vectrex empty directory, and I think I called it simple, so it's very inconsistent. All right, we made it. Okay, so there is CRT0. Great. If I hit F5 here, okay, so here's main. So here we go. So let's go in there. So we grab our first line. Okay, so there it is with the many, many backslashes. Probably because it's being escaped here. There we go. So it is a string. We grab our S. Just turn off my notifications here. Oh, cool. So I actually got that one right. I always get like off by one errors with these offsets when I deal with substrings. So now we know we're going to grab the next line. So the next line, whoops, the next, what's happened to my call stack? The next line is here. So does that make sense? It does. So the next line ends in foo-minus 5000. Cool. So we got line, we've got next line. So what we should be doing now is replacing this last bit with the full string that's in there. So next stabs, it is indeed a stabs. And we grab its string portion. We do our erase. Let's see if I got that right. And looks like I didn't. All right, and that's also not going to be correct because we need to replace a portion. Oh man, we don't want to append to the whole line. So I don't know why my erase is not working, and in order to do this, I'm going to have to do an insert, not an append. So that's okay, we can do that. Oh, and that's why my erase didn't work, because I'm erasing from the end of the line. Okay. Gross. And the thing is, I don't know the location because I'm using this regex thing. All right, so maybe we'll be less yeah. You're saying I would probably just extract the string parts first and put them somewhere together and then merge lines as required in the second pass. Yeah, that's an option. That's an option. That's definitely more efficient, but ultimately I'm still going to have to do the thing of like extracting. Like, it's almost the same. Basically, rather than do the insertion here, I could just accumulate into a temporary string and then at the end do the insertion into the main line itself. Yeah. The only reason I like doing it like this though is that if I do that, I'm gonna have to know that, no, I mean, it's not a big deal. I could do it that way. But one thing I cannot escape is I need to find the location of the first place of that, like this bit here. I need to remove this, I mean, in the original string. So I'm gonna have to do an extra find there. Let me think. Okay, so let me go with what you said here. Let's try and do like yeah, that's true. Yeah, I could do that. I mean, find last of. So you're saying, yeah, I could basically search through the string, the whole string for this bit here, because we know it's there anyway, right? Okay, so let's start with, I like your idea of accumulating, actually. I like that. Let's do that. I think that's going to make it more, even easier to understand. So we'll do, I don't know what to call it. Isn't stitchstring just a terrible class? It's just terrible. I think rfind will do the trick, like a reverse find or something. Okay, so let's do this. Let's call this for lack of a better word, I'll just call it joined, and we'll do this. So this I can do that too. We will start off with, okay, so we're going to grab the, I do need to do the erasing though here of the last two of the S. No, that's not right. Just give me a second. Just have to reduce the heat in here. It's like super hot in my basement right now. Okay, let's just work through this. So grab the string, take out the string part, then if it has this, read the next line. Yeah, this is not good. This is not like the clean way to do this. I'm gonna do it like sort of. I was almost there, and then I'll like think about how to rewrite this in a cleaner way. But what I think I'm gonna do is I'm gonna do the kind of find. So is there an rfind? Yeah, there is. So let's do the reverse find for our friend here. And in fact, I guess I don't have to do that. Line.insert. And in fact, I got to remove it. Yeah, so let's do this. Did we say find returns? Actually, maybe an index wouldn't be so bad. I need like an, I think we can insert, can we insert where indexes? Or does it have to be an iterator? See, it accepts, okay, it does accept offsets. So we can do a find last of. I know, I think it is rfind, but at the same time, I need to remove and I need to insert. And if I have an iterator and I remove at the iterator, can I still use that iterator to insert at? Certainly I can do that with an index. That's sort of what I'm thinking. You know what I mean? Is that not what I want? Find last of? Oh, the last character. Oh, yeah. Yeah, okay. Yeah, not the whole character. Yeah, that's true. That's true. I'm sure I know this, and I probably had this here. You know what? Let me just use my replace, which actually does the right thing. I think. Maybe it doesn't. Actually, yeah, I think my find first of is probably doing the wrong thing as well, isn't it? So these don't look for find character in string. Yeah, you're right. Yeah, that's not good. So yeah, it is going to have to be our find. But oh, but these do return it. Okay, they do return positions. Sorry, because I was under the impression that it returned a an iterator. Okay, so we can do that. So we'll look for that. Make sure it's not npos. Can't be because we know it's in there. And then we'll say line dot erase at offset index for 2 characters. And then line.insert at this offset, and then the value itself. Did I see that it does it not accept a string? Or yes, indeed. I should probably write my own string class. I mean, clearly I have my own string utilities, and probably what's going to happen is that something in here is going to become more string utility functions. Okay. What I want to do is add s here. Okay, so I think this should work. I think that this tonight's stream is going to end with me just trying to get this part to work, and we'll have to go to parsing enums and all that on Thursday because it's getting a bit late. Okay, so this is the wrong file. This is main. So let me write here s. Okay. So we do our find, got our index, that looks wrong. Oh, sorry, I gotta be looking for in line, not in S. Okay, 98. So let's see what happens now. This should erase this bit here, which it did. And it's going to insert, because now we can see here, it no longer has that. It just has that comma. And then it should insert S there, which it did. Foo -5000, comma, semicolon. Now it should say we're done the while loop. Now we're done here, and our line that we output is the concatenation of both. So that worked for this one. So that's cool. Let's take a good look at this and extract it. I just want to like have it here so that I can. So this is what I actually extracted from these two lines. Let's do this here. Okay, that looks good. So let's do the next one. So the next part is going to be for this multi-line struct. Okay, so we're going to parse that guy. Okay, just let it do that. Here's the next one. So there's our struct line. So we should parse everything out in this loop here. So do this, grab S. So that's the what ones with C, yeah. Our find, index, erase, and insert. That looks good here. And there's the double backslash. So now this should loop again, and it does. Erase and insert. Okay, it's looking good. I think it's the last one here. Yeah. Okay, so let's take a look at what our line looks like all concatenated together and see if it makes sense. So there it is. And it is supposedly the concatenation of all these lines here. Let me remove some. It's very confusing. There. Okay. Okay, so we've got that bit there, semicolon, followed by yeah, this looks good to me. Success, indeed. So yeah, definitely not the most efficient implementation, you know, with those removals and insertions. But, you know, could be optimized later type of thing. Yeah, I mean, at the same time, we have to think that this here is just for the portion of the like when we start the debugger, it does this parsing, right? Like it just parses all the RST files and accumulates all the debug information from these stab stuff. Once it's done, all these allocations are gone, and then we move forward. So it's this one phase, like the loading phase. So I'm not too concerned. And it's already, you know, it's fast enough kind of thing. So I'm not too concerned with the performance of this bit. I'd be more concerned with, say, while you're debugging, things that can take a long time because that can affect the actual debugging experience, but not so much the loading. So yeah, I wanted to, yeah, that's another valid point. Yeah, Vectrex programs tend to be pretty small and simple and don't have like super complex types with lots and lots of values. So that's a very good point. I am hoping that at some point I might be able to use this. Like right now it's for Vectrex, but there are, you know, probably other, I don't know, maybe. Thinking maybe there's a way to like reuse this for other embedded systems that, you know, generate stabs. Because that's what stabs is for. It's like this older debug format that's generated for like targets that don't really have elf or dwarf, that don't make use of the elf format. So maybe. Okay, so what I want to put here was the, I'm going to just give this a name, like a, what do you call that? That token, the line continuation? Did I have like const? I did. I'll just do that. Okay, let me just leave it like this. So we got this get line here. Now I kind of feel like I'm just going to leave it here because it encodes the information of the fact that we are parsing out strings. I'm just going to add a little comment here, and I'll say stab string lines that are too long are extended over multiple consecutive lines by adding a token at the end of the string portion. Example. And I'll say, okay, for example, I'll give an actual nicer example here than my ugly one. So when this happens, or to simplify parsing, we detect these and join these. We detect this case and join, or anyways, to simplify parsing, we join all these lines into a single one. Don't do that. Okay. Getting Clang formatted by my line length here. Okay, so that's good. So now we have a way to not have to worry about the multi-line thing. So we're going to end up parsing this for enumerators, and this for structs that have many fields, and keep the parsing code really simple. I can have a simple regex and all that. Although, yeah, it won't really be a simple regex. It'll be more like a split. That's what I'm going to be doing. I'm going to be grabbing like this bit here, or this bit here, I should say, split on the comma, and then for each one, split, like grab the split on the colon to get the key value pair. So yeah, that's gonna have to wait till Thursday, guys, because it's time for me to end my stream. So thanks a lot for watching, and if you're interested in seeing me continue on this, I'll be streaming again on Thursday, same time. So thanks a lot, and I'll catch you next time.